Hi there, boys and girls, and welcome back to Conquering Math, where it all adds up. Today we will be learning about equivalent ratios. Let's dive on in. By the end of today's lesson, you will be able to create ratio tables in order to find and identify equivalent ratios. The Common Core State Standard today is to make tables of equivalent ratios relating quantities with whole number measurements, find missing values in the tables, and plot the pairs of values on the coordinate plane. You will use tables to compare ratios. First, we need to discuss what equivalent ratios and ratio tables are. Equivalent ratios are two ratios which express the same relationship between a set of numbers or objects. For example, in the picture below, there are 4 blue circles to 6 red circles. Or we could say that there are 2 blue circles for every 3 red circles. Ratio tables. Ratio tables are a table used to find equivalent ratios. In this example, we have quarters and dimes, and we have 3 sets of equivalent ratios: 3 to 4, 6 to 8, and 9 to 12. Example number 1. Using ratio tables with addition. We will need to complete the ratio table, then list each equivalent ratio that we found. In this case, we are comparing fish to birds, and we'll start with a 2 to 5 ratio. When you use addition in a ratio table, you always add the simplified ratio. In this case, the ratio was 2 to 5, so we always need to add 2 to the number of fish and 5 to the number of birds. To get from 2 to 4, we need to add 2 fish. To keep the ratio the same, this means we need to add 5 birds. So now we have a ratio of 4 to 10. In the next step, to get from 10 to 15 birds, we need to add 5 birds, which means to keep the ratio the same, we need to add 2 fish. This will give us a ratio of 6 to 15 fish to birds. The equivalent ratios are 2 to 5, 4 to 10, and 6 to 15. Example number 2. Solving ratio tables using multiplication. We will need to complete the ratio table and then list each equivalent ratio that we found. This time we are comparing 10 bikes to 5 scooters. When we use multiplication in a ratio table, we always multiply both sides by the same factor, just as we would when we find equivalent fractions. Initially we have 10 bikes and 5 scooters. In the second step we know that we will have 10 scooters, so we need to multiply 5 times 2. In order to keep the ratio the same, we must also multiply the bikes times 2. 10 times 2 is 20, so we found our second ratio. Now to move to the third step, from 20 to 60, we need to multiply by 3, which means to keep the ratio the same, we must multiply the other side by 3. So we find that the number of scooters is 30. The equivalent ratios are 10 to 5, 20 to 10, and 60 to 30. Example number 3 will be a real-world example. Zara is making her own colorful silly putty at home. She needs to use 4 drops of food coloring for every 6 teaspoons of silly putty that she makes. How many teaspoons of putty did Zara create if she used 15 drops of food coloring? We'll start by creating a table with food coloring in one column and silly putty in the other column. We will insert our initial ratio of 4 to 6. For this problem, we need to plan ahead because we need to get from 4 drops of food coloring to 15 drops of food coloring. 4 is not a factor of 15, so we can't just multiply straight to get there. In this case, we'll actually use division to get from 4 down to 1. Then once we figured out that ratio, we can increase from 1 to 15 drops of food coloring. This will use the same method as multiplication. To get from 4 drops to 1 drop, we need to divide by 4, which means we need to divide the right side by 4 also. 6 divided by 4 is 3 over 2, or 1.5. Now to get from 1 drop of food coloring to 15 drops, we must multiply by 15. This means we also need to multiply the right side of the table by 15. 3 halves times 15 is 22.5 teaspoons of silly putty. So Zarra created 22.5 teaspoons of silly putty and used 15 drops of food coloring to color it. For example number 4, we will need to find two ratios that are equivalent to 6 to 14, and this time we will do so without using a ratio table. We can use a method that is very similar to finding equivalent fractions by multiplying or dividing each number in the ratio by the same factor or divisor. Starting with 6 to 14, I've chosen to multiply first, and I've chosen to use the number 3. 6 times 3 is 18, and 14 times 3 is 42. So 18 to 42 is equivalent to 6 to 14. Next, we will follow the same method, except this time I've chosen to divide by 2. 6 divided by 2 is 3, and 14 divided by 2 is 7. So 3 to 7 is equivalent to 6 to 14. It's important to note when solving these problems that you can multiply by any factor you choose, and you can divide by any number that is a common factor of the two numbers in the ratio. So there are many different options, and your options may not always be exactly the same as the options in the solutions video. Today you learned to create ratio tables in order to find and identify equivalent ratios. The Common Core State Standard today was to make tables of equivalent ratios relating quantities with whole number measurements, find missing values in the tables, and plot the pairs of values on the coordinate plane. You also used tables to compare ratios. Now that you are familiar with these techniques, complete the independent practice problems in your guided notes packet. Then watch the independent practice solutions video to check your work. Thanks for watching this episode of Conquering Math, where it all adds up. I'll see you next time.